this is an orbit. So pink planet orbits the yellow sun. I'm going to reset this. It takes two things to make an orbit. One of them is the inertia or velocity of the planet, and the other one is the mutual gravitation between the two. If I take one of them away, I unfortunately cannot take gravitation totally away, but I'm going to reduce the mass of the sun, which reduces gravity between the two by a factor 200 in my example here. Hit the start button, and the planet will just take off in a straight line because the gravitation is so small that inertia wins, and that velocity, which in the case of Earth is 30 kilometers per second or 20 miles per second, 70,000 miles per hour, just takes over and the planet is gone. So I'm going to turn gravity back on by increasing the mass here, but this time around I'm going to turn inertia off. So the planet has no velocity, and the obvious thing will happen: due to gravity, it crashes into the sun. Okay, I'm going to reset it and put it back to the initial numbers. So here's the velocity, here's the velocity of the inertia, here's the gravitation between the two. Hit the start button, and the two combine to make an orbit. And that's actually it. Question for a later day is, well, where did the velocity come from in the first place? That's when I will talk in a later lecture on the formation of the solar system. And one other thing you can see here is, I'm going to do this one here. So I'm going to start this one here. You do see the mutual gravitation actually between the pink planet and the sun, because the sun itself is wobbling, so they have the same gravitational force between them. But of course it makes much more of a difference to the pink planet because it has 200 times less the mass. The yellow sun has 200 times more mass. It makes less difference on it, but still the same gravity between the two. And again, overall, to produce the orbit, it takes the inertia and gravitation to be combined to produce an orbit.